Hey guys, I'm gonna walk you through a little Excel exercise dealing with net present values and expected values. So I'm gonna display a screen here that shows the beginnings of a problem. I'm gonna go through it super fast because it's all copied in the video description. All right, we're considering building a new project that costs $200 million, spread out equally over 5 years to make it. This could be a factory, a new office building, whatever. In this case, I'm going to use the example of a dam because I'm making this for my environmental econ class, and so it'll give us some fun things to talk about. It takes 5 years to make. We build it during years 0 through 4. In year 5, the dam is operational and should operate for 60 years. We discount future costs and benefits at a 7% rate. While it's operating, $9 million a year in operating costs, $14 million a year in recreation benefits, $7 million in hydropower benefits. I have a scale here for environmental damages. It increases by 2 per year. So 2, 4, 6, 8, 10 during construction, and then is 10 every year after that as well. And then there are flood control benefits, which 65% of the time there is no benefit because there wouldn't have been a flood. In a wet year, roughly 1 year out of 4, randomly, 30 million of damage is prevented. And in a very wet year, roughly 1 year out of 10, 70 million of damage is prevented. There's also earthquake risk, where every year there is a 0.01% chance that an earthquake causes the dam to fail, in which case it would do 10 billion in damages. So what is the net present value of this dam, and should I make it? Let's review 3 equations you're going to need here. One of them is the present value function. The present value of xt, well, xt is the cost or the benefit in a given time period, is equal to xt over 1 plus r to the t. T just being the time period, r being the discount rate. When you get a discount rate like 7%, don't put 1 plus 7. 8 would be wrong. Convert it to a decimal instead of a percent. So 1 plus 0.07 is 1.07. All right, next, the net present value is where we had a bunch of x's that were part of some larger variable x, a bunch of observations of the same thing. Well, for the net present value of x, you just sum up all the present values across time. And then last one is the expected value function. The expected value of some variable y being a random variable with multiple outcomes, is equal to the sum of the probability of each specific outcome of yi, times the value of that outcome. So we'll demonstrate that in a little bit because we're going to have to do it twice for these two. In the meantime, let's switch over to Excel and go for it. All right, here we are. I've already recorded some of the information. You'll notice that for construction costs, the 200 million, I've made that be a negative number. Operating costs, 9 million, negative number. Environmental damages, any sort of cost I'm making be a negative number because that's going to be working against us. It's a negative value. The recreation benefits, the hydropower benefits, the flood control benefits, those are all positive numbers because those are the good things we get out of this. Now, a couple of little side notes just for the way I set it up. 200 million for the construction costs, but it's spread over 5 years. So this is going to be minus 40 per year if it was spread out evenly, which I'll usually assume it is just for convenience's sake. Let's see. Environmental damages are going to be minus 2 1 year in year 0, minus 4 in year 1, minus 6 in year 3. Okay, blah, blah, blah. 2, 4, 6, 8, 10 for the 5 construction years, and then our 10 every year after that. Now, the flood control benefits and the catastrophe risk, these ones have random components. It's a random variable, and we can't just put a value in there. So we're going to put in the expected value before we bother doing any of the present value stuff. So let me imagine for a minute, here's if our yi, the outcome of random variable, has to do with our flood control, whether the flood didn't stop anything, or whether the flood control stopped the little flood, or whether the flood control stopped the big flood. Let's see, let's say P of yi, and we'll do a separate one just for yi. P of yi are these percentage terms. We're going to put them in probability form, so 0.65 for 65%, 0.25 for 25%, and 0.1 for 10%. Those should add up to 1. If not, you probably forgot something. And the outcomes for these, 65% of the time, no costs or benefits. 25% of the time, 30 million in benefits. 10% of the time, 7 million in benefits. So now I'm going to create the P of yi's. And by the way, if you want me to do this like handwritten, like algebra style with the expected values, I have a video on that too. Go find it. But P of yi times yi is just equal to the probability of yi times yi. So we'll do that for each of those. Okay. And the expected value then of y of our flood control benefits is equal to the sum of all of those P of yi times yi's. Suggesting to us that although most of the time our flood control has 0 benefits, and then a quarter of the time it's $30 million of benefits, and 10% of the time it's $70 million of benefits, on average, we expect this thing to have $14.5 million of benefits every year. So it's a weighted average of these probabilities and their outcomes. I did it pretty pedantically here, multiplying each probability times its outcome in a whole separate column and then adding them up. But that is what we were looking at here. All right, let's do it for the catastrophe risk. The idea that the dam might fail in the event of an earthquake. Let's see, let me just get rid of this stuff so it doesn't confuse us. Event, catastrophe, dam breaks. What's the probability of it? 0.01%. So not 0.01, that's 1%. 0.0001. That's the probability of the dam breaking at any given year. And what's the outcome? Negative $10 billion, which I'm writing everything in millions, so that's minus 10,000. Now, the other 99.99% of the time, there's 0 problems here. So what's our expected value? It's equal to the probability of failure times the cost of failure plus the probability of nothing happening times the cost of nothing happening. And it's going to come out to be -1. Okay, so let's get rid of all this stuff. Put a 14.5 there as a benefit and a -1 there as an expected cost. I'll just bring this stuff together. So I had to do that to get the expected values so that I can plug our random variable into all of our present value stuff. So let's get to that now. If you read our book, or probably a lot of your books, there is a table of sorts where we total up all these costs and benefits. So I'm going to start with doing a year, and then I'm going to do a column for each of these other things. Construction costs, operating costs. Now I'm going to highlight this row and hit wrap text. And I'm also going to widen these columns a bit so that I can read everything a little bit easier. That's just personal preference. If you already know what's there, you don't have to worry about it. So my year starts in year 0. It goes 0, 1, 2, 3, and so on. I think I said it's going from, I think I said it'd be 60 years of operation. So there we go. 5 years for construction, that's 0 through 4. 6 years of operations takes us all the way to 64. I don't actually want to look at all of it at once. That's not interesting to me. So I'm just going to hide a whole bunch of it. Personal preference. It'll be easier to read this way. Highlight a bunch of rows, hide them. Okay. So we see the beginning of what it looks like and then skip and we see the end. I'm going to do this the pedantic way, where first I'm just going to build the cost table as if there were no discounting. All right. Just to help us make sure we know what all we're looking at. Construction costs are equal to the negative 40 per year. I'm going to hit F4 to freeze it on that number for the first 5 years. And after that is 0 for the rest of the life of the dam. Now, by the way, if I unhide this, you'll see that it filled the gap with all the zeros. So whenever you drag through the missing stuff, it still goes to all the missing stuff. Or whatever you're doing goes to all of it. In this case, a bunch of zeros. Okay, operating costs. None of them during the first 5 years. But after that, the operating cost was a negative 9 per year. Okay. Recreational benefits. None during the first 5 years. But after that, it's 14 per year. All right. Hydropower benefits, 7 a year. Environmental damages. This one I did a little bit trickier. In year 0, does $2 million of damage. In year 2, does $4 million of damage. In year 3, it's 6. In year 4, it's 8. In year 9, did I say that all right? 0, 1, 2, 3 is where we're at. Year 3 is minus 8. And year 4 is minus 10. And every year after that is still just minus 10. Again, remember, these benefits here are positives. These costs are negatives. Okay? Flood control benefits. None while the dam isn't in operation. But after that, 14.5 million a year in benefits. At least their expected value. Freeze that, do that. And catastrophe costs. The dam failing won't mean any problems until it's done, but once it's done, we expect to lose about $1 million a year. Which means most of the time there's no problem, but every once in a freaking while it blows up in our face. But on average, it doesn't show up too much. So, side note to like the precautionary principle or risk aversion or something. Not getting into that in this video. Okay, this is what our table looks like if we don't discount the future. If we didn't discount the future, that's all of our stuff. And we could total for each category. Add up all the construction costs. And I'm just going to drag this sum all the way over to all of these. Let's even do one more just for everything. And that would tell me that I expected this dam to have a $700 million value. But if we discount the future, it's going to be a lot less than that. Because these early costs with no benefits will have higher value per dollar than these later time periods where there's benefits outweighing the costs. So let's redo this table and let's do it with net present value instead. So let me copy it real quick. Oh, man, I'm going to hide a whole bunch. so we can see it all at once. And I'm going to call these NPVs for each variable. And we're going to start completely over. What we're going to do is we are going to take every value in here, and we are going to use our present value function to discount future payoffs. And then we're going to add them all up for those bottom row, for that bottom row, and see what the net present value is for each variable and for the dam as a whole. This part's pretty straightforward, I guess. I am going to take my construction in year 0. The present value of it is equal to the construction in year 0 divided by 1 plus R, and I said R was 7%, so 1.07 raised to the T, my year. Okay, it's that. And you'll notice that for year 1, there's no change whatsoever. But for year 2, there is going to be a difference. We drag these down. You see that the $40 million in year 1 is $37.38 million today. The $40 million in year 2 is $34.9 million today. And then I didn't show 3 and 4, but they're in there. Now, if I want to get some fancy Excel work, I mean, I could do this calculation manually for each row or each column, but another option is if I look at this, I know I want my year to stay the same for every row, but I'd like for my operating costs to go with operating costs, my rec benefits to go with rec benefits, my hydro benefits to go with hydro benefits. So I want this E73 number to be stuck in column E, but I want the F4 to be flexible and follow the variable. I don't know if that makes sense to you. Hopefully you've got a little bit of Excel training before we're doing this video. If not, well, come talk to me. Or if you're not in my class, then good luck. Or just do it all by hand. I showed you how to do it once, do it a few more times. So I'm going to freeze my year in column E by putting a $ in front of the E, but not the 7.3. I'm not just going to get F4 once to put $ on the E and the 7.3 because I want the year to be able to be flexible. I'm just freezing the column that we're in. Now, when I do that, it won't change these at all, but it means that I can just go like this, blam, and everything is getting properly discounted. So, yeah, by putting the $ on the E, it froze E so that all of these, no matter which column we're in, are tying the discounted value to the year instead of it dragging across for construction or operating costs or whatever. I'm just rambling at this point, guys. It's been a long day. Sorry, I'll shut up. All right, net present value for each variable. Net present value of the construction costs is equal to the sum of all of these discounted construction costs. The $200 million spread across 5 years is worth $175 million in today's money. Drag this over and I can see my net present value of a whole bunch of stuff. And let's do our total NPV, so these are the NPVs for each of these variables. 96 million in operating costs over the life of the dam, $149 million in recreation, but okay, etc. over the whole life of the dam. What's the total NPV for the whole dam? It's just equal to the sum of all of those NPVs. Ooh, this dam's not profitable. That sucks. That's funny, right? Because if we don't discount the future, it is by quite a bit. But we are discounting those future values enough that those future payoffs don't justify the short-term costs. Now, if the discount rate was lower, we'd probably go with it. Okay. Actually, yeah, let's try that and just see. What if the discount rate was 5%? Let's just see what would happen. Yeah, if the discount rate is 5% instead of 7%, all of a sudden we have a positive NPV. If you discount the future too much, the future payoffs aren't worth it. If you discount the future less, those future payoffs matter more to you. Guys, I hope this video was at least a little helpful. I know I was fairly pedantic, but if you're new, that's probably a good thing, right? Yeah, good luck with those dollar signs in Excel. They'll be your boon if you learn how to use them. They'll be your curse if you don't. Otherwise, you can just do each of the columns manually and it'll be fine. So thanks guys for watching. Good luck. Happy econing.